technical interview is unlike any other job interview. It's a tough and rigorous process that tests your coding skills, problem-solving abilities, and personality. But it can get a lot easier if you're well prepared and know what to expect. Join Interview Kickstart's co-founder, Ryan Ballas, in a 1-hour interactive webinar on how you can crack technical interviews at top tech firms the Interview Kickstart way. We have helped over 5,000 engineers receive life-changing offers from FAANG and Tier 1 tech companies in the US. Your dream company is just one step away. Sign up for a webinar today.
Mock interview scheduled for Scalable System. So imagine you're working for a startup company. So basically, I'm going to ask you for some broader questions to define some high-level components. And then we will do a deep dive into a specific user journey. Okay. And we will ask you about design components that's needed for that journey. And then we will ask a little bit about how you're going to handle scalability issue. Okay. So that's going to be the structure of the interview. Mm-hmm. Okay, if you don't have questions, then I'll get started.
Yeah, I guess I do have a question. So you mentioned, first, just to make sure I understood, we're going to first talk about the overall system, and then we're going to go into the individual components, and then from the perspective of the user journey, and then dig into things. Is that what you're saying?
Yeah, roughly, but
okay.
I will be mainly driving the flow. Okay. It might be a little bit different from the interview Kickstart structure, but just a heads up.
That's fine. Okay.
Okay, so let's get started.
Yeah.
So assuming you work for a startup company that would like to build an e-commerce website similar to Amazon.com, and you are the architect for it, maybe the first question is, what are the key components needs to be considered?
So I'm going to write this down just to make sure I don't forget anything. So the key components that I can think of immediately are essentially some way to store a product catalog that can allow it to be searchable. So I guess the data of the products, and the data would include things like the price, the producer. I guess a couple of questions. Do you imagine it being like a marketplace, or do you imagine it being like Amazon is like the actual vendor, like Amazon Basics or something like that? Or how close are we approximating Amazon.com?
Yes, that's a good question. I guess I would say we can do both.
Okay. So in that case, the nature of the data would probably be matching like individual fulfillment vendors plus Amazon's own inventory. So I guess two different kinds of inventory: the kinds that are owned by Amazon, the kinds that are provided by participants in this marketplace.
Right.
So all of this data would be about the products. So there would be that, and then there would also be a large component that would allow the search and the investigation and the discovery of these kinds of products. And I think part of that also has to do with like ranking, potentially sorting, based off of reviews, based off of like prices, different ways to slice the data up. So like product discovery, some kind of product discovery arm. Also, like the customer-facing marketplace, and what I mean by that is the UI, the portion of the web that services the actual customers that go in to purchase it. So there's two sides of that. There's the view for the fulfillment vendors, for the independent vendors themselves, as well as Amazon's internal tools that allows them to manage their inventory and sell online, and then the customers themselves that see all of this data mixed together. So I would say that there's more like a user-oriented experience there as well. I can think of a couple of other things. I mean, those, broadly speaking, are the three things that stand out to me. There's a couple of other things that I can think of as well. Things like maybe some partners will have. Okay, fine. We can stop.
So you have the three things you mentioned. One is, I think, is discovery related. One's customer facing marketplace. The other is the inventory management, the inventory facing system for vendors. Is that correct?
Yeah.
Okay. Yeah, I think that okay. There might be some stuff missing, but we'll cover it. Yeah, we'll cover in some more like deep dive. Yeah. Okay, so going into a little bit detail. So let's say you build a site, and then the user comes to your site, and then they added item to their cart, and they come to the final screen. Say there's a button there that says complete purchase.
Oh yeah.
Right. So what happens in your system when user clicks on the button?
Yeah, that's one of the pieces that I completely forgot about, and that's really everything that has to do with the actual purchase and transaction, and there's also the logistics that go behind that. Yeah. So, walking through your particular question, when somebody clicks on that button, there needs to be some business logic that's performed that takes the payment information, the shipping information, the account information for this user. Obviously, they made a choice about when they want the product to be delivered. If they want, for example, one within 2 days, then it goes down a certain path in the logistics arm of the company, and if they can wait for more time, then it goes down a different arm. But when they click on that button, what I imagine happening is there's some kind of validation, some kind of check that says that authorizes the actual payment, and that generally means that Amazon, this website isn't a bank or anything like that, so there needs to be a third-party call that goes out to a partner website, and it could be something like they're like a Stripe, or for example, or some kind of gateway processing vendor, and they will take that information and authorize it, charge the card, and then come back to our website saying, yes, the charge is good. Go ahead and the funds will be transferred. You can go ahead and ship, or it's going to say that purchase didn't work out, and we've got to then bubble that error out to the user so that they can either use or pick some kind of other payment form. There's also a check that makes sure that the inventory that's in the cart actually can be shipped out, that it is in stock. But I think for the purposes of this, I would like to make the assumption that if they can put it into their shopping cart, that item is temporarily reserved, and then we don't have to worry about the inventory problem during checkout.
Okay.
If that's reasonable.
Okay, so you mentioned two things. One is a payment process. One is inventory check, but it may not be needed.
Right.
Right. Okay. Cool. So, if we let's say I want to dive a little bit deeper here. So, I think you described like sort of like the workflow, but can you draw like what are the different systems or services or components that's needed to handle this workflow, and what's their relationship?
Yeah. So I'm not super handy with Google, so I'll try to move as fast as I can. And it may not be pretty, but I'll see if I can make this work. So I guess the first piece is we need to have some kind of database, something that's going to store all of our information. I'm not sure. This may relevant change order goes. And the reality is there may be several different kinds of data stores that might be that we might use. So I'm thinking right now, product storage, account storage, authorization, configuration, things that encode and sorry, things that components that describe the nature of the relationships and API, things like API keys that are used with external vendors and third parties. For the simplicity of this, our conversation right now, I'm going to just say that all that is stored in some kind of data store, although in reality it could be like something like a Zookeeper or Redis or some kind of NoSQL or SQL database. Beyond that, I'd say that there's also some kind of if I'm thinking about this as like a microservice architecture, I think that might make sense. There may be something that has like a payments gateway, a payments microservice essentially. This for now. And this component here would be in charge of requesting from third parties that these payments have been authorized. And the responsibility here is when that response comes back as positive, then some facade layer, some orchestration layer is going to say, okay, the payment came back good. Let's go ahead and signal to the logistics department that they can send out the product itself. So I'm going to see if I can add this as a different thing that's showing that it's going out to the internet. And that could be, for the sake of argument, it could be something like Apple Pay, something along those lines.
Mm.
Okay. And then above that, above this payments microservice, I think that we'd have like another layer, like some kind of orchestration layer. Let's call it just an orchestration layer. And here in this orchestration layer, there would just be like business logic. And what I'm thinking is, if we go all the way to the front, there's potentially just a React component, a React single page app that would essentially house this. React SPA, just keep it simple. And we would basically have the React SPA would basically live outside of on the browser. It would live on. It would be essentially served up by some kind of web app, and maybe this web app is essentially what our orchestration layer is doing. We can call this the node, for the sake of argument, the node web app. So since it's React, it would basically, it makes sense to use something like Node to service this up, because you can prehydrate, or you can inject the data into the React SPA on load, and then you may not necessarily have to go back and make an API call once the page loads. And everything over here essentially lives behind this firewall, and there would be load balancers in front of the major components. Probably use as a load balancer in place. Some kind of So the request would essentially come in from the browser all the way up to the ELB, into the firewall. The ELB would presumably have multiple node web apps to services to maintain uptime. This node web app would basically make an orchestration call out to another ELB that would be in front of the payments microservice. Just copy that. Let's see if I can get this connected. So that would be one thing that would happen. This node web app would be accessed by the browser using HTTP calls. When the request comes in, authentication is definitely going to be a problem. Just on a high level, I would expect like some other component here to handle authorization and authentication. Create a component here. This is kind of, I apologize, it's going to be like all over the place. And in the life cycle of every request that comes in, authorization and authentication, typically by a cookie or some kind of JWT token. Presumably somebody logs into a system and gets that token that identifies them. Realizing that there are different ways of managing and maintaining authentication state. There's like the whole store the session in something like a memcache, or store the session somewhere. I've worked with systems like that where every time you do a deploy, sometimes it triggers something up and then people get kicked out of the website. Today, and at Vestwell in the past, I've defaulted to using something like a JWT token that contains some kind of user identification, and then permissioning that way can be calculated dynamically, so that if in case somebody needs to get kicked out because they no longer have authorization, then you can do that in real time. Since this is this kind of system doesn't really warrant necessarily that kind of level of real timeness. I think it's probably fine. I don't think that there's any reason not to use it, but I do like the model for having that kind of flexibility in the future. So within the request, let's say that this request comes in, it hits an ELB, there's a node web app. Somewhere in this chain, we need to authorize and make sure that this person is who they are and that they're authorized to make that request. If it's this kind of authorization scheme, might not actually live in this particular workflow. We can set up some kind of user login process where a user identifying token with a kind of persona association with it can be defined. So if you log in as a customer, you would have a different set of permissions than if you were like an inventory or an internal Amazon employee. So for this particular request, I'm going to assume that has already happened. They're already authenticated into the platform, and that this authorization service will have been invoked earlier on in the stage. So we don't necessarily have to do that authentication. We'll know who they are. So for example, a user ID that's encoded as a UUID could be passed into this request as an SP from the browser. Then, and based on the URL context, it could be something like /customer/purchase, something along those lines, to kind of make sure that we know that this request is coming from a person that wants to buy something. So given that this is a user that we can identify, the Node app would then have to hit the database and pull up some of the information that's already stored. I would imagine that in this scenario, there might be a situation where we're already storing some of the credit card information, and because we're a scrappy website, a scrappy startup, we're probably not going to be PCI compliant. So we may outsource something like this to something like a Stripe, which means that we might have another third-party API call to make that. Well, I guess let me take that back. If we were to use somebody like Stripe would actually be in charge of holding on to the credit card information, like the actual digits. Stripe is PCI compliant. Then that's something that we don't have to worry about. So in this case, what we would pass out to the Stripe API is some kind of token that we have on our end that identifies the intended customer. And that could be like an encrypted, special encrypted or hashed identifier unique to Stripe within their ecosystem. So the request comes in, we assume that we're already authorized and authenticated. The Node web app pulls the information from the database that we need in order to construct a call to the payment service. And that might be the product information, that might be anything that's in the shopping cart, the intended destination, the timeline essentially for when we want the product to be delivered. But the first step in this is, okay, now we have this data, we need to go make the payment call. So then that's when it hits payments microservice with the appropriate payload that has the total cost,
Right.
that has the Stripe customer's information, so that Stripe can make the charge. And then whenever Stripe comes back, if it's a good, we're going to be able to move to the next step. There is something else that I just thought of that is important as well, and that is we need to probably have some way of calculating taxes or calculating the total cost. And let me see if I can just add. It's definitely a complicated problem in the sense of that it's local, federal, and different. There are taxes and tax amounts that need to be applied depending on your geography. There probably needs to be a service that kind of abstracts that out and we break that out into a separate component that just worries about what the total cost is given whatever's in the shopping cart. And I'm assuming here that we're going big and global. So as we expand to different geographies, the complexity in this total cost component could become much more significant. VAT versus sales tax at a local, state, and national or regional level could vary. So that's something that we want to also incorporate into the process before we hit the payments microservice. Okay. Assuming, I can go into this probably a little more, but I'd like to make sure I get to the rest of the question. So assuming that, I can go back to that later if you'd like. Assuming that the payment comes back good, then we need to make some kind of call to an inventory service or some kind of logistics-related tracker that will allow us to mark the item as purchased, and then start collecting some kind of list of items that we need to collect from our warehouse or from our vendors, so that we can actually put together the package and then ship it out. I don't know entirely how Amazon does this, but I'm going to venture a couple of reasonably educated guesses, and I'm probably going to be completely wrong with a lot of this. But for the sake of argument, let's make an assumption that we have a warehouse, and in our warehouse, our independent third-party vendors are all sending all of their merchandise to that warehouse. To keep this simple, let's just assume that there's one big warehouse in the middle of the U.S. I know in reality there's warehouses all around the world, and there's whole systems of logistics and support to be able to manage this. But for the sake of this question, And I can dig into how I would imagine that would be put together afterwards, but I want to make sure I get to this question. If this inventory were to say, for example, just manage one really big warehouse, then I would like to make the assumption that this particular warehouse would the operations arm would make sure that this warehouse honors whatever is in the inventory that's marked within the data within this entire section here. And what I mean by that is I'm going to make the assumption that whatever is in the inventory data component, that is what we actually have. I don't want to worry about what happens if there's a missing inventory or if it's mislabeled or anything like that. Yeah, those are exceptional cases that we can probably go over later. I'm trying to think of a good, maybe this would be like a good just a warehouse in general. And if we pretend that is our warehouse, this inventory is tied very closely to our warehouse, and our warehouse is where everything basically would need to be coming out of. Like whatever's in the warehouse needs to be displayed in the inventory, this inventory service, and this inventory service needs to show everything that's in the warehouse. And this inventory service, I haven't drawn it out, but I would imagine that it probably has, it definitely has its own database potentially. It may not be related to this database in general, but I want to call it out that a lot of these microservices might have their own data stores in particular. But for the simplicity of this conversation, let's just assume that they're all inside this one big database. Okay, so this inventory service, once the payment comes back, this inventory service, we're going to ping it and we're going to say, hey, these are the things that a customer has purchased. Let's put these into in motion. Let's start collecting them and getting them ready to ship out. So once we have, so then in this case, the inventory service would go and make sure that the items are in stock, and make sure that we have workers that can go in and go grab all those items. So sorry. Essentially, it would have to be an asynchronous request, in that it would say there's no way to in real time collect it immediately. So it is essentially going to be like, okay, we've got these payments. Let's send an async request out to the inventory to get this sent out. Let's go deliver this. We're good. So in other words, there's no need for this customer to wait for the inventory service to come back. It's just, I've clicked it. I'm good. My payment is good. Let's go ship it out. So this request is basically saying, go ahead, go. And this inventory service is actually pretty interesting, I guess, in that case, because I could think about it as, I'm thinking about it as like some kind of queue that processes orders as they come in. And then it may take some time to fulfill the order. And then fulfilling the order, there could be things that go wrong with it, but assuming that things go well, the end state is ultimately that maybe it means once it's actually shipped out, there's a tracking number that gets generated by Amazon's couriers or the post office or FedEx or whatever other vendor, and that would then be able to be echoed back to the user, and whenever that's completed, some kind of offline async notification could be emailed to them or pushed out to them if they're on a mobile device. Okay, so there's definitely a lot more going on in this inventory service here. I think that in a way, the experience of the users when they click on a purchase is to verify payment and then kick off the order. But there's a lot more going on in this inventory that I think on a high level, I think would make sense to get into. But I think that as a purchase, this is on a very high level what I imagine happening.
Okay, yeah, that's great detail. Thanks for sharing. I want to make sure I fully understand. I think the flow you're drawing here is essentially the Node web app we'll first check the payment to make sure the payment goes through, and then if that goes through, then you will sort of calling the inventory service. That's essentially will also inform the warehouse to maybe initiate shipping or order processing there. But at a high level, this is like the 2 steps I'm hearing. Is that correct?
Yeah. That's right.
Okay. So some questions. I think you jot this total cost on the top. So is that like a separate service you're going to call, or?
Yes, absolutely. So I'm calling this out as essentially like another step in this process. At the very basics, this is the overall thing that happens. But total cost is what I'm thinking about is like, VAT. Like, what about VAT, tax, sales tax, regional sales tax? Sorry, it doesn't feel close. And the concern here is we need to know what this total cost needs to be so that we can then send out as a request to payments microservice. So then this actually would be something like, if you can hear me. This would first make the call to the total cost to calculate what that looks like.
Okay.
And then it would call out the payments once this total cost has been calculated, and that's what actually gets charged.
Okay, so that's like separate service.
Yeah. I'm not quite sure what a good name for that is yet, but it's essentially the purpose of it is to make sure that we can charge the right amount of sales tax whenever the item's purchased, but we may not know that the day that or at the time when the purchase is made. Right.
Okay. And the other question I have is, you have this database thing on the right side. While you also mentioned the inventory may have a separate database. So what is this first database you're drawing? How is that being used?
Yeah. So I'm sorry, this wasn't really. I didn't do a good job of being clear. Like, every one of these microservices could potentially have their own database, and that can come in many different shapes and many different forms. What I did want to represent here was that this is the place where all the data goes, and that could be like a data center, multiple data centers. I just wanted to make sure that that was something that was accounted for. But in reality, this inventory service likely has its own database. Maybe it has its own, maybe it's stored in NoSQL, maybe it's stored in relational, maybe that's in a separate part of the country, maybe it's on site. But whatever strategy is employed here, I know that the data needs to be stored somewhere. And this was just a general call out for all of the microservices that there is some data component that's being stored somewhere. I can definitely go into each one of these and into how I would imagine them working, if you'd like.
That's okay. Maybe we can go into a little bit detail on the inventory side. So we definitely will have a database for inventory, and I wonder, like, what's that database relationship versus warehouse? I think it's not super clear to me. Like, these two are a little bit similar, but it seems to be serving different purpose.
Absolutely. So I'm going to draw a little bit more over here, so that we can talk about it a little bit more. I mean, it's been my experience in the real world that, sometimes you'll see something that's marked in on a website or in an inventory somewhere, and then you go back to the warehouse or somebody comes back to you and says, hey, actually, that was mislabeled. We actually don't have that in stock. So there's the representation of what is supposed to be in the warehouse, and that would be part of what's in the database. Transactionally, what we expect to be there, and then in the warehouse is reality. It's what we actually have, and sometimes they can get misaligned. And I think I was hoping to call that out earlier and say, I want to assume that these two are very tightly coupled and that there's no anomalies here. But in reality, it's a good call out. It's saying, there may be a shipping, maybe a box was mislabeled with the wrong items, or maybe we received the wrong items from the supplier. That happens in the real world. If we break that assumption and we say, okay, we need to actually reconcile that with reality, one way we do that is by storing what we expect to be in the inventory in the database. And I believe that there are processes inside warehouses that go and make sure and spot check that the items of whatever's inside the warehouse matches what's expected in the roster, in the inventory roster. So I think that from a customer perspective, or actually more from like a fulfillment request perspective, the inventory service would ping the database because that's what's intended to be there. But then like some human would then, I would imagine that then a shopping list, a list of things that need to be put together has to be generated by this inventory service and sent to the actual warehouse. And then in the warehouse, a human being would have to go item by item, picking up or fetching the items from the individual aisles and from the individual shelves, putting them into a bin, and then packaging it all up. Now, if they go into the warehouse and there's an item that's missing, they would need to have a way to echo that back to the inventory and say, "Here's a checkbox. I'm crossing it out because that item wasn't there." We need to go back and update the inventory data and make sure that that's more consistent. And we order new supplies, or we account for this anomaly somehow.
I think that sounds reasonable, but how do you actually implement it? So is that something you correct at real time, or is probably, or is that something that you cannot do real time?
Sorry, to be clear, which do you mean, the correction if there's like an anomaly, like there's expected inventory but it doesn't exist?
I guess there are two parts. One is the anomaly part. One is for the part let's say the order goes through. Like how does inventory and warehouse they talk to each other? I guess there are two parts of the question.
Got it. So what I would imagine is, once the inventory service gets this request, they don't geographically have to be in the same place. It could be like a data center in West Virginia. The warehouse could be in California or New Mexico or whatever. But the inventory service would be in charge of producing a shopping list, some kind of shopping list, and that could be in the form of a digital email. It could be in the form of entering it into the database, and there's potentially another website that's internal and customer facing for warehouse, for the warehouse employees, so that they can log in. Maybe they'll log into the warehouse app, and then that would guide them. What I'd like to do is build them like a website that gives them daily tasks. So as soon as a new inventory item comes in, they can look at their daily task agenda and see that list come up. And then when they see that list, they could see all the items that they have to pick up from the physical warehouse. They'd go to the warehouse, pick all that stuff up, and as they're going, they could tick off one little checkbox for every item that they're picking up until the order is fulfilled. And once the order is fulfilled, then they'll move it on to the next term, which would essentially be the packaging. And if there's a problem, if there's an anomaly, that website, that little app would allow them to say, item is not in stock, I need to reorder, or some systems may be more sophisticated and say, this item can also be substituted with another item. So that could be something else, that could be a feature that the inventory service could offer. If we don't have this item in stock, do you have any other options that you would like to fulfill this with? And those are some things that I've seen that could work. But ultimately, like whenever that warehouse app detects that either there's an anomaly or that it's been as complete as possible, then that order is filled, and if there are errors, we bubble it back to the user. If not, then we ship it.
I see. So essentially saying it's a warehouse employees that's going to be act on correcting the anomalies.
Yes.
Okay, I see what you mean. Got it. I have two more questions before we end the mock session. One is for the inventory part. I guess one thing we didn't talk about is so let's say the user on your side was trying to buy something, but they added to the cart. However, that is already sold out, right? But they added to the cart, and they already kind of initiate the purchase or order flow. So how would your system handle that case?
Yeah, that's a good question. That's something that's very disappointing when it happens. So let's say that I purchased something, and then we make it all the way to the inventory, and so there's a warehouse employee that goes in and tries to find the item, and they don't find it. They mark it within our warehouse SPA React app. It goes back to the inventory system. So at this point in time, there are many ways to do this, but one thing that I think could be helpful here is maybe having some kind of event-based architecture that would say, this event just happened, let me go publish this or push this this event out to some kind of system, and then the system could distribute the event to the appropriate listeners. And I'm thinking something like a Kafka queue or something like that could be useful in generating this kind of collaboration, where then a different service would be in charge of listening for this kind of event. And maybe this would mean we could have another inventory exception handling service, whose job would be to to be an intermediary between the inventory and the customer experience arm, and that would be essentially like a way to trigger some kind of notification. There are two things that need to happen. We need to trigger notification to the user that the item wasn't actually in stock, and we can either present them an option to get the money back, or we can offer that they can wait until the item has been fulfilled. So let's quickly talk about both. So if they want to have the money back, at this point we've already charged this payment. We could either offer them a credit or give them a refund. And I think it's much more convenient for us if we offer them a credit. But let's say that they want the money back. Then in that point in time, this inventory exception would probably need to ping the total cost service up here to understand what the breakdown would be from the actual item plus minus the involved sales regional tax, and then make a call out to the payment service to issue a refund for that difference.
Right.
And then once that happens, we would send a message back to our customer. And actually, another thing that's missing here is some kind of push notification component. I'll just add it down here. Or just customer notification. Kind of notification component. And the reason why I want to be a little vague about this is because this could be anything like an email service, or it could be an iPhone, or some kind of SMS service, or some kind of other way to get the messages out to the customer. It's just a component that's in charge of push notifications out, and this could be accessed by anywhere in the system. It would just need to be set up properly. So the second thing is, if the item's no longer there, they could also just opt to say, that's okay, I don't need it right now, I can wait until the next time that the warehouse is fulfilled. And that could be, then in that case, we don't have to make any changes to the payments. We just make sure that item's queued in some kind of back order service potentially that might be a component of the inventory service. and it just goes into a queue, and whenever the warehouse is fulfilled again, if those items are fulfilled again, then that item that's been queued up can come back. And there's actually, now that I'm talking about that out loud, there are other things that we need in order to help support and maintain the warehouse there, which could be like a back order service. Right now that I'm thinking about, that's probably event-based. Whenever items are entered into the warehouse, that it interfaces with that in order to help update and make sure that the inventory is up to date.
Right. Okay. I think given time, but I do have one last question. Let's say you can finish in 2 minutes. So what happens? Let's say Black Friday event is coming, and wonder what could potentially be the bottleneck in your system to handle increased traffic, and how can that be mitigated?
Yeah. So I think there's a lot of stuff that could definitely go wrong. So Black Friday, known for spike traffic, known for a lot of people logging in and getting as much information as they possibly can. So the first thing that stands out to me is obviously this third-party API. Like, if people are going to be purchasing a lot of things, that this could get a lot of traffic. If we make the assumption that Stripe just isn't going to go down, they're handled to scale, then it's not as scary. But that is a concern. So how do we handle that? Even in the case where something like a third party like Stripe would go down, well, we could implement some kind of like queue or caching strategy. We could probably we could take customers potentially. I think that's a problem I'd like to think about a little bit more. But another thing would be just heavy read traffic coming into the app. So the Node app is in front of an ELB. We would need to make sure that anytime we're hitting the database, any one of these microservices are hitting the databases. We want to try to cache as much of whatever is reasonable, so that we don't have to bog down the actual database with inbound requests, whichever of these databases may be. So Black Friday, I think, is an interesting mixture of a lot of read requests and a pretty reasonable amount of write requests, because a lot of transactions are going through. But I think there's definitely a lot more read requests than there would be writes in that sense. A lot more people are shopping versus actually buying. I don't know what that ratio is off the top of my head, but because of that volume of much more read, anything that's read of any data that is of read type, we want to make sure that is easily accessible and cached, so that any requests that come in, they don't have to wait for a database connection to pull that out. So I can see reasonably some caches behind potentially the local VAT sales to regional tax. That could be easy, because that generally doesn't change very often, I would imagine. Authentication and authorization could be another good place to cache. Payments, I don't think might be, off the top of my head, might not be a good idea to cache, because that has financial consequences if we get that wrong, and we have to work in arrears. Inventory could be cached, provided that the cache policy is in accordance with however we manage the warehouse. And what I mean by that is the warehouse, the inventory isn't going to change. How do I say this? There are big events that happen when the warehouse, when new shipments come in. The requests that come in for inventory, the hot items, those could reasonably be cached, because they would be accessed quite often. But the challenge there is, when something comes off the cache, how do you manage that so there's consistency across the database and the warehouse and the cache itself? So that, I think, is a little bit trickier, but I think it can be done in the sense of where the request comes in, and then it goes all the way back to it does a write out to the actual data store, but on the write back, maybe it'll go back to the cache. So then the next time, that might not be like a good strategy.
I think, yeah, maybe let's end here.
Yeah.
I think overall you did great. I probably just will comment on a few things. Some could be nitpicking. I think the first one is initially we talk about the high-level system. Yeah, I think as you mentioned, you missed out the entire payment or transaction or ordering flow there. The second one I have noted down is I think it's good you mentioned the relationship between inventory and the warehouse. However, I guess some technical things that could be added there. You might mention when you were talking, but it's not super clear to me. Like you mentioned that it's a warehouse worker's responsibility to deal with anomalies, but I just felt how scalable that would be if you have like so many, let's say, third-party vendors joining on board, and also as you scale up, and this will be a big cost factor potentially, and also could be error-prone. I'd be a little bit cautious there to see if this can be automated. And if you want to automate that, I guess we can have like two-way conversations, like two-way conversation between inventory and warehouse. Like inventory, for example, in the inventory database, it thinks something there, but warehouse couldn't find it, then the inventory should probably remove that record, at least for now, or reduce the quantity. I think if warehouse added something but inventory doesn't have yet, then warehouse should notify inventory through some queues, or could be online or offline jobs, that's the new items being added. And normally, I think I mentioned online and offline, like the offline one could be sort of like a daily job or something that does a sweep through to do a complete sync across these two. And online could is more like real time, but in case like online job fails, then offline job would be able to catch up. So that is one thing I would add. The other thing comment I have is on the. Before I move on to, do you have questions there?
So just to make sure, so you're saying like thinking about the warehouse as like its own thing, and potentially even having its own database, its own application / database to interface with the inventory, right? Is that what you're saying?
I think that makes sense. The way I see it is like, inventory is consumer facing. Oh. So right. So if consumer like browse your website, see the product details, or maybe do the searches, I think those are all powered from inventory, not a warehouse. So that's that's where you distinguish. And warehouse is more like internal facing. And I think these two characteristics can also imply when you say later if you want to scale up your site, then maybe you'll probably focus on inventory, but not warehouse. Because inventory traffic will be huge, but warehouse is not huge.
Yeah. And at the end, I think I started thinking about that, but I didn't surface any of that, and that was a missed opportunity. I think you're right. Thank you for that.
Okay, that's more. The other thing, remember I asked you what happens if a user adds something to the cart but it's not available. I guess there one thing we didn't dig into is at which stage we kind of guarantee sort of like guarantee that the item is reserved for the user. I think your idea, if I understand correctly, is that the card itself is sort of like a reserve, has a reserve function, right? So if you add to the cart, then we reserve that particular amount for that product for you. Is that correct?
Yeah, definitely didn't go into that too much, but yeah, I think that's an approach that I think I've heard about or that I've seen, but I know that has like some issues with it too.
Right. So that's where I want to be cautious, because for example, you can add something to the cart, but you won't. But there is a so in e-commerce, there's a sort of like a user funnel, right? And there will be percentage of users who will drop out of the flow in each steps, right? From the discovery, from search, from detail page, from cart, finally to the purchase. So every step there is a percent of user dropout. So if you reserve the inventory at the cart step, that means there could be say 20-30% reservation that didn't end up getting completed, and that could cause issues, especially say Black Friday when something is on sale. There's only 100 items available, and 80 of them were purchased, but 20 of them were reserved, and no one can grab them. So yeah, I would be cautious on that assumption there. So yeah, so that would, yeah, I think you can think about after, like if we don't have the assumption that we reserve it as a cart step, then how do you handle the exceptional case that if you at the cart step you have the item, but when you check out the item is gone? So how do you do it? Right. Okay, one last major comment I have is I think there is a missing like ordering table or ordering service. Yeah, the use case would be we probably need something to keep track of users' orders, so they can, both for internal and external purpose, right? For external, that the user can keep tracking of their order history, and for internal, we should kind of keep a map of the order and the product that's included in the order, and how which inventory item, like or warehouse item that mapped into this thing in the order. So I think that is a missing piece.
Yeah. I completely missed like any kind of metrics in quantification around order trends, things of that nature. I completely missed that. Correct.
Yeah, exactly. It can be used for recommendation system later, maybe. Okay, let's see what else. On the final question on the scalability part, I think caching is definitely going to be helpful. I would also introduce a concept called ordering queue. So where if you say your site cannot handle huge traffic for payments, or cannot handle huge traffic for this ordering transaction, then say if you can only handle like 100 QPS, then for the request that's above 100, then you can keep it in a pending status or something, and that would be processed when your resources are freed up. I think that could be an option you can consider. Because for transaction, it's different from like loading the page, right? Because people can wait, right? It doesn't need to come back to them immediately. Yeah, I think I have.
That was really helpful. If you don't mind my asking, I feel that sometimes I rush through a lot of things, and at the beginning I felt a little, certainly a little clumsy when I was working my way through like drawing the components. I guess from your perspective, is it more important to talk through? I'm sure I'm going to get a little bit better at this, at drawing, but how much of an impact is being organized about this drawing and versus talking out loud and thinking through the problem itself?
Yeah. I think drawing, to me, I think drawing probably is more important than you're covering everything you're talking. The reason is the way I see it is what you draw is represents the most important things in your talking, or the key items in your talking, and also it's just more visual to understand your thought process better by connecting dots of various things. So if you can turn your talking into the drawing, I think you already did great here. But I do agree. I think you talk a lot more than what you're drawing. Yeah. So if you think something you're talking is important, then see if you can be reflecting drawings one way or the other.
I guess last question for me is like how was like my communication on it? I mean, I think I was trying to talk out loud and think through out loud, but I don't know if that's helpful or not, or if that's what you'd like to hear.
I think it is great. Overall, I think the way you're talking is good. Only thing I'll be cautious. Nothing is bad or something. It's that probably you probably should can find some balance point between. I know, like for example, when I ask a question, you will maybe talk around the question and also kind of extend a little bit, talking things that maybe I didn't ask, or so there's going to be a balance that you sort of like try to impress the interviewer. The other thing is then that means the interviewer will have less time to ask maybe more important questions later on. For example, we didn't have time to. We actually did not have time to ask a scalability question at all. So, so I would just maybe check the clock and see if you have ample time. Then sure, you can talk a lot. But if you only have, let's say, 10 minutes left, then I'll just be precise. Yeah.
Got it. No, that's very helpful. Thank you.